Good morning, everybody. Thanks for joining the webinar for the RIEGL Topo-bathy. Joined here with my good colleagues here at Whiteout Solutions. I'm Tyler Shriver. I'm the ULS sales engineer here at RIEGL USA, handling sales and any integration on the drones. I'll pass it off to Evan and Paul here to introduce themselves.
Hey everyone, thanks for joining us and thanks for RIEGL for hosting. Evan Carlson, the Director of Product and Business Development and one of the partners here at Whiteout. And yeah, excited to share what we're doing with the Topo-bathymetric LiDAR technology provided by RIEGL. Paul?
And my name is Paul Burrows. I'm Vice President of Sales here at Whiteout and looking forward to talking to you all today.
Perfect, thank you. We'll go in here. We'll start off talking about the technology, some of the use cases, then pass it off to Whiteout to really dig into what they're using it for and kind of some of the results. To start out here, we're going to first discuss the RIEGL Topo-bathymetric LiDAR operations and technology here for UAV solutions. I'd like to first start out with just kind of a quick overview of bathymetry for some of the audience members who may not be as keen with the technology. To start out, what is bathymetric LiDAR? Well, bathymetric LiDAR is a type of LiDAR that allows for collection of surfaces and objects below the water. Your normal topography scanners are a near IR scanner that don't penetrate the water. With a bathymetric scanner, it's a green channel laser that with its wavelength, you're actually able to penetrate through water and get surface returns. Secondly, I'm going to open up a poll here actually. Are you familiar with what a Secchi depth is? I'll leave you here for a second. Seems to be a pretty good mix of new users and people are pretty in tune with it. A Secchi depth is actually the measurement of how turbid water is. Well, with this, how deep is a Secchi depth for those who do know what a Secchi depth is? Don't mean to wake everybody up on the West Coast with a little bit of a quiz. Probably didn't know you were getting a pop quiz this morning, but so a Secchi depth is the measurement of turbidity of water, as explained, but turbidity of water does change depending on where you're at. So the penetration of bathymetric LiDAR is variable. With this, a Secchi depth in the Florida Keys in the off the coast of Australia might be 20, 30 meters versus if you go to the mouth of the Mississippi in New Orleans, your Secchi reading is going to be extremely low, where you're not going to get penetration through the water. And then finally, how do you measure a Secchi depth? Well, to measure a Secchi depth, you'll use the object on the right, which is a Secchi disc. You lower it down in the water, and to the point where you can't see the disc anymore is 1 Secchi depth, which explains how the reading is variable and does change depending on the turbidity of water. Now, after getting some of these base terms out of the way, what are some of the benefits of a UAV bathymetric LiDAR? Well, it's quicker collection of bathy data compared to your traditional survey. You have less boots on the ground, less people in the water, less people in areas you don't want them, in flowing water in areas that are a little harder to get to. With this, it is a much quicker deployment compared to your traditional methods. Setting up a drone and flying it up and down a river corridor, a creek, along the side of an ocean is a lot easier than actually convening everybody. It's a lot easier to deploy than manned aircraft in these upstream riverine environments where putting a crew together and getting in areas where it might be heavily forested or narrow, where your turns might not be as conducive to the aircraft. You do collect more precise data compared to a fixed wing manned aircraft. This is mainly due to the altitude of the scanner, but you do collect more precise data. And with these Topo-bathymetric LiDAR sensors, you are able to collect both the topo and bathymetry data. Now, this being said, it doesn't completely replace a topographic scanner, as they are better at the topography. This instead collects the bathymetry and your context outside of it. So the shoreline of a river, the beach along lapping ocean, alongside the rock sides on the side of California, so you can have context to put in. RIEGL does have two UAV bathymetry solutions, the VQ840GE and the VQ840GL, with the difference here being the E stands for economic solution. The VQ840GE is locked in more compared to the GL with less options. For example, the measurement rate for the GE is from 50 to 100 kilohertz, with the GL being selectable from 0.5 up to 200 kilohertz. This in turn means the 840 GL is capable of up to 2.5 secchi depths of penetration, while the VQ840GE is only capable of up to 2 secchi depths of penetration. With this, the precision is the same. Your laser beam divergence is the same. However, your receiver field of view is locked for that VQ840GE, but not for the GL, showing more selectiveness. With this, the VQ840GE is about half the cost of the VQ840GL. However, you're locked in with options. You don't get quite the, you can't build out exactly what you want possibly. With this, we do offer full integrated solutions for these scanners. The 840GL has the option of an APX20 IMU90, an IMU82, or even an AP plus 50 IMU91 for your dual use helicopter and UAV solution, and is optional with a 24 megapixel camera. Following up with the options you have for the GE, this is sold as a complete bundle, with the only option being an APX20 IMU90 and a 12 megapixel camera being integrated. With this, both these scanners are capable up to data storage up to 5 hours of operation, meaning you can run multiple flights with these without having to run into any data storage issues. To tap in on the near elliptical scanning, this is quite a bit different from your nadir scanning. Your field of view isn't quite as large. However, you will have it cross over twice just because it is an elliptical scanner. This is going to come in play for your actual flight planning. To help with flight planning, RIEGL does have its own calculator to figure out, what is your swath width, what's your height, what's your NOHD of when you're flying, called RIE parameter. So with this, what you'll do is actually plug in on the left side what your options are going to be, such as your laser beam divergence. This will come in for your NOHD and your ENOHD, so your nominal optical hazard distance and your enhanced hazard distance. Your flight parameters, such as how high do you want to fly and how fast do you want to fly. We found that really a lot of the sweet spot for your height is 75 meters with these drones, and your speed will determine your point density. This will then give you your swath width, which in this case is going to be 54.6 meters for a swath, or relatively 180 feet, meaning you're collecting about 180 feet of data in a horizontal pattern at a time, with your lateral separation between strip lines being about 143 feet. Your laser safety information is extremely important with these lasers, as they are a class 3 laser and do have a hazard distance to them. The nominal optical hazard distance here shows below the 100% mark, meaning someone without any enhanced optical devices can look directly up and not be harmed by the scanner, while the ENOHD shows over 100%, meaning if you are passing over a beach or somewhere on a lake. If someone does look up with binoculars, there's a chance of that laser pulse hitting their eye. To follow up, the RIEGL and Whiteout Solutions has paired with Harris Aerial to deliver this full integration. The Harris Aerial Carrier H6HL was selected due to its high payload capacity, being NDA compliant. It does have, with this scanner, it's capable of 30 to 40 minutes of flight time, depending on the environmental conditions, and is equipped with PWM triggering for both acquisition and safety. Given it is a class 3 laser, you don't necessarily want to start it on the ground. You want to start collecting once you're in the air, which is the main reason for our PWM trigger. The data processing workflows. So RIEGL's data processing software is called RIProcess. Through this, we'll bring in the raw data and make it into a usable point cloud. The raw data is actually calibrated, aligned, and georeferenced to whatever coordinate system you define within the software to then spit out an actual usable point cloud. Through this, it'll go through RIUnite, and for any sort of refraction correcting, we'll actually go through RIHydro. So the way the RIEGL refraction correction works is it automatically classifies the water surface points. From here, it will generate a water surface model. And then using these two pieces of data that it's gone through, it can determine the correct laser penetration, do refraction correction, and show points below the water correctly. As so the data doesn't show up as one bundle of random data points. It'll show the water and your models below as well. What are some of the use cases for these? Some of the bigger use cases are riverine environments, areas with difficult to reach in manned aircraft. It's difficult to get some of these manned aircraft in these tight, windy areas, especially some of your fixed wings. It's a lot easier to deploy a drone quickly. As well as wetland marshes, with the ability to collect both topographic and bathymetric data, you're able to decrease the number of people on the ground and times you need to go out to collect. If you're able to collect the points on the water as well as your topo points, you don't need to fly a scanner for one and then the other, or fly a scanner and then send men out to actually do traditional wet survey. Other use cases include the intercoastal waterways. It's a lot easier deployment to get 2-3 people out flying a drone than round up a whole team and find the best time to fly for manned aircraft. This relates to nearshore mapping, submerged and man-made objects such as dams, docks, and piers. These are usually in tight, hard to reach areas, and maybe a lot easier. And then with this, we can also merge with topographic data. While you might get the context from the cliff sides or the beach with this Topo-bathy scanner, you're also able to merge it with traditional topographic LiDAR or data to get an overall full picture of what might be a stream in the middle of a large mountain pass. Thank you for joining me, and I'm actually going to pass it off here to Whiteout Solutions to really go in on how they're implementing the technology and some of the results they're getting.
Excellent, thanks, Tyler. Great. So as mentioned before, we're Whiteout Solutions. We're based in northeastern Vermont, and the company was founded in 2016 and very much focused on delivering end-to-end solutions for geospatial data, from the collection, processing, analysis, and automation through the delivery in our application called GeoSap. Our background has really been in LiDAR technology since the founding. Matt and Christine, who founded Whiteout Solutions, spent the first few years actually developing their own LiDAR package, doing sensory fusion of GPS, IMU, and LiDAR systems to develop a more affordable UAS system. And then since then have really shifted to put our focus into kind of two primary areas, being the field services side, where we're focusing on the Topo-bathymetric LiDAR acquisition and hyperspectral imagery. And our primary methods for collecting are UAS, and we do some work with helicopter. We're working across North America, soon to be actually entering Canada, which we're pretty excited about. And then, doing all the data processing, analysis, a lot of custom deliverables, and working in an array of industries, but really a big focus on environmental restoration. The other side of our business is actually the software side, where we are developing the data delivery application and processing suite with GeoSap, and then really taking the custom analysis processes and building automation around those. So that's a little background on us. Our path to getting into topobathy really started in 2019 when we were working with the University of Connecticut on a pilot. Their researchers wanted to utilize LiDAR to understand the effectiveness of various sediment restoration techniques that they were doing in the coastal marshland of Connecticut. Over the course of a few years, we had flown thousands of acres, and the LiDAR was actually extremely effective for being able to help them validate their work. But we found a couple challenges where there was definitely some holes in the data, specifically in those areas like the runnels and channels that were near shore, any of the micro topographies. Those had data gaps, as you can see here in this image on the left-hand side. The other challenge was definitely we were racing against tides constantly, trying to always fly our LiDAR flights at the lowest tide possible in order to be able to get the most data possible, but finding ourselves just not always able to get there at the time or complete a flight before the tides had actually risen. A few years later, we were contracted, actually last year, we were contracted by the Connecticut Department of Energy and Environmental Protection to survey all the protected coastal marshlands in Connecticut, about 14,000 acres. And we knew at that point that probably the best way forward was going to be acquiring a Topo-bathymetric LiDAR system, which at that point we made the acquisition of the RIEGL 840GL and have since been using it. The system is still quite heavy, though it's mounted on the UAV, and so for that we actually had to have a specific class of UAVs, and we're trying to thread a number of different needles, specifically carrying a 20-pound payload, plus having something that was NDAA compliant so we could actually get federal work, and then we wanted a minimum of 40-minute flight time. And so we ultimately landed with the Harris H6HL, which is a heavy lift system, and we had to get a Part 107 exemption in order to be able to actually fly the system. So a little background there. So Topo-bathymetric or traditional survey certainly has their place. The methods tried and true, but they definitely have some challenges. Wet surveys can be accurate, but certainly dangerous, especially when you're in rivers or areas that have risky water scenarios, and they aren't providing a holistic data set. The remote boats provide bathy data, but aren't giving you anything on land and challenging to navigate, and similarly don't provide a holistic view of the environments that you're surveying. The publicly available data sets typically come from fixed wing aircraft and are lower resolution and many times out of date, and also run into similar challenges that Tyler had mentioned before. So ultimately, the traditional survey methods produce lower resolution data and reduce the confidence factors in the actual models that many of these data sets are going into. From our experience over the past year or two, we really, like any aerial survey, planning has been key to the success. We go through our standard planning processes. We do remote site inspection before we go to any site or take on any job, really looking at historical data and occasionally LiDAR to be able to understand elevation. We're looking at flight authorizations, especially with our heavy lift exemption. It takes more time to just kind of verify that we're meeting all the different requirements associated with that special authorization. Tyler mentioned the sensor settings. We've spent a lot of time in RIEGL parameter in the past year or so, really refining the settings and getting comfortable with what we know is going to work in each environment. And there are quite a few things that are needed that are Topo-bathymetric specific. And the goal really is to verify or to reduce the variables and ensure that we're getting the best possible data for the customers and that we're getting ground returns when we go out. So we're looking at things like the weather. The weather window is typically 7 to 10 days out. And similar to a traditional aerial survey, we're not flying in high winds or rain and ice or kind of cold weather, but we're also looking for really any events that are going to stir up turbidity and reduce the ability to actually reach the bottom of any of the areas we're surveying. We also look at NOAA's storm gauges or stream gauges, typically 3 to 5 days out, trying to look for kind of what the normals are for those areas, and then validating against it as we get closer to the survey date, just to make sure that the water levels are indeed coming down and that there's again a lower risk of turbidity in the water. When it comes to coastlines, we're looking at tide charts relating more to the depth of the water. At high tide, there's instances where you can't actually reach the bottom. And so we're just trying to make sure that we're targeting the times that are going to be best for actually flying. And then, of course, secchi measurements. If we have a partner that's on site or close to the site, we usually will have them take a secchi measurement for us in advance of going out and doing our own inspection. Maybe it's 1 month out, it's certainly a couple weeks out, and that gives us just a sense of what is the actual water today versus what it's going to be when we actually get on site, and be able to really understand how much change is happening in that area. The other factor that was new to us was certainly the time of collection. The sun angle really can impact the quality of a survey and provide false returns. And so, i.e., don't be flying at noon. Flying at night is ideal, but also harder to get that nighttime authorization for flights. So we thought we would go through some kind of samples of how we've been using the system and some of the data that we've collected. The system has given us an opportunity to really collect a wide array of projects and in various environments. So it's been pretty fun to be able to see all the different use cases come to life. Many of the projects that we've done have been kind of in the rivers and wetland environments. The top left is actually a survey in Florida or Georgia, and what I love about this survey is that it's a shallow wetland stream and under relatively dense vegetation, and we could still penetrate through the vegetation and the trees to reach the actual bottom of that stream, which again is super unique and not something that most traditional airborne LiDAR sensors are going to be able to do. On the top right there, we have a floodplain study that we supported in Vermont. And Vermont, like many other states over the past couple of years, has seen quite a bit of extreme flood events and that are impacting communities around the region. And so many towns are working with engineering firms to be able to come up with solutions to reduce flooding. And this is essentially a data set of a river corridor, and what's really nice is that you can actually see a lot of the geomorphic features, the erosion, the deposition, scouring. So love that one. Then we have on the lower left-hand side the dam section, which the dams, there's tremendous value here in that the kind of traditional methods used can be pretty dangerous for being able to understand what's happening at the actual impoundment areas, and then really getting an understanding of what's happening in the spillway as well. Like, what's the quality of the actual spillway? Is there any damage to the spillway? and understanding just the infrastructure as a whole. So next we got the ponds and lakes, and so another great use case. While we haven't done a ton of that work and we haven't been contracted to look for kind of lost vessels or hidden treasures, we're definitely open to it. So let us know if you have any thoughts on different use cases there. So we've also spent a lot of time in the past year or two working in the coastal marshlands and beaches. Coastal marshlands, last year we flew 14,000 acres of protected coastal marshland in Connecticut, which that data should be completed late this summer. And as far as I know, I think is one of the largest high resolution UAS Topo-bathy data sets to date. So pretty excited to see where that lands and be able to share that data out with everyone. Then beaches. So we conducted a survey with Scripps Institute of Oceanography. And this was really looking at kind of multiple different methods and trying to compare single beam versus multi-beam versus topo-bathy. And so, this data set for us was really cool because it was the first time we actually got to see the sensor kind of reach close to the max capacity from a depth perspective. And you can see here, it's like pretty close to 40 feet. And so I think we're at 38 feet there. And then you're also going up to the cliffs that were like 150 feet. So very cool to see that. And then we have infrastructure, which is another really great use case. Tyler had mentioned it, but like seawalls and jetties, ports, etc. Another great use. And then for the last one that I personally like as a surfer, I'm very interested to see these kind of wave analysis, being able to see that kind of top water surface and then the topography underground that actually is helping shape those waves and how it's actually impacting the kind of wave analysis. So lastly, I want to show a quick fly through of a river corridor we did recently. So this really just kind of shows some of the various deliverables that we produce, whether it's a classification, being able to highlight the elevation, and really just showcasing the best of the data that we can actually produce with it. And with that, I'm going to hand it to Paul to give you guys a rundown on some of the other solutions we're offering. Oops.
Thank you, Evan. Real quick, I just wanted to touch base on our GeoSat platform, and we mentioned it. Evan mentioned a little bit earlier, and what we found is that when we're dealing with UAV topographic surveys, especially at the scale that we're dealing with in areas like Connecticut, it's a lot of data. And we developed a software suite to manage the big data problem with both LiDAR, hyperspectral, multispectral imagery, and workflow processes that really streamline all the analysis steps that we do. So this platform can handle both point clouds and imagery as well as vector data, and it can build different analysis, scripts and tool sets to do the analysis directly in here. The powerful thing about it is that it also produces a visualization platform for users that are non-technical. So users that can go in and look at point clouds, look at imagery without having to have a GIS background or a CAD background, or be able to really democratize high quality geospatial data throughout the enterprise. So it really has, and it also has some reporting capabilities to allow you to export and share different data and results with everyone else in the organization or potential clients or pretty much anyone, whether it be a board of supervisors, that sort of thing. So it's really a collaboration tool that we have developed, and quite frankly, we're our own biggest client on this because we use it every day in our data collection analysis. And I'd be happy to answer any questions you have on this. Next slide, Evan, if you could. And kind of just to summarize what we talked about today, just kind of what we're doing with the A40GL, as well as our software suite and all the reprocess tools, is its end-to-end collection and analysis for a variety of different use cases. A lot of our customers are asking us to do multiple temporal, so we'll come back year over year and see how things change to see how different environmental conditions are really impacting that site, and really trying to enhance. It does replace in some sense the traditional survey, but really it enhances it because of the resolution and accuracy, and additionally the safety that we get through it. And then we could also use the GeoSat platform to deliver data and democratize and share data across the organization. And it being a UAS platform, we can really get to hard to get to areas, or areas that may be obstructed by trees, mountains, that sort of thing. It's really agile platform at a very, very high resolution. So that's it from the Whiteout side. I guess we can take any questions. Both Evan and I's contact info is there. And I think we'll pass it back to Tyler and open up for any questions we have.
That'd be a good one for Paul, you and Evan. Can you talk a bit more about the difficulty in obtaining the Part 107 heavy lift exemption restrictions on flights?
Sure. So, I mean, I think the first part is just the process of actually getting the exemption. I was surprised, honestly, how long it took. You know, you can go through the process with the FAA, and there's a lot of the 44807 exemptions that are actually occurring. Ours took 6 months or so to get, and that was quite a bit longer than we had expected. So I think, you know, just a tip on that is to get in front of the process as soon as possible in order to be able to ensure you're not holding up the actual work.
Perfect. Then, you know, how would you decide to fly on a heavy lift platform versus a helo? And then what kind of depths are you seeing from the 840 GL? Depths will definitely be dependent on whatever kind of environment you're flying in. Evan, I guess, what kind of depths were you seeing in your riverine environment?
Most of the riverine environments we're actually getting pretty solid penetration. In Connecticut, all the data we've seen thus far is getting between 15 and 20 feet down. Most of the marsh areas that we're surveying are barely that deep, and so we haven't had any issues actually getting bottom returns there. And to the kind of second part of the question relating to the decision to fly helo versus the UAS, it really comes down to actual total number of acres that you're trying to fly, especially in some of those larger marsh areas where you're looking at a mile of distance, you know, just going from one side of the marsh to the other. And in those environments, it's just much more efficient to be able to put a helo in the sky and be able to survey those. But the smaller, you know, 200-300 acre areas, we're doing those, anything up to kind of 1,000 acres. And then at that point, we start kind of making that determination. But yeah, I think that pretty much answers it.
Yeah. Kind of skip around here. Dave asked for Part 107, kind of stick with the drone side. For your Part 107 exemption, are there additional guardrails with your exemption for flying, or are you able to fly as you are a Class 2 UAS?
There are similar, and I think it really comes down to what you put in. We had a lawyer that we worked with to kind of define the use cases that we were going to be utilizing the system under, and then that was really what was written into the Part 107 exemption. All those exemptions are actually publicly available on the FAA site, and so if you wanted to get into the details of it and see what's in there, you can actually go look.
Perfect. And stick with the drone side. What was the reason you picked the UAV? Well, the reason we chose Harris Aerial is actually proximity there, and just, you know, overall usability. They're located about 18 miles here from RIEGL USA, full NDA compliant. Multiple drones are on the blue list. They, you know, worked well with government agencies over the years, and overall just supplied a reliable integration. And have been extremely easy to work with in terms of actually getting this solution up in the air.
Yeah, I would say, just kind of echoing what Tyler said there, Harris has been really great to work with, But in addition to that, really, we had, as I mentioned in the slides, a bunch of different needles we were trying to thread with, flight times, NDAA compliant, being able to do heavy lift. And the other thing that, I didn't mention in the presentation much is we're flying not just the Topo-bathymetric system, but we're also flying our hyperspectral camera on the system as well. So having the capacity to do both sensor systems on a single UAV is unique, especially with this kind of weight that we're carrying.
Perfect. To get a little more of the data quality, how does it detect vegetation underwater, and then will it give ground under the water, dense vegetation? So it is a line of sight scanner. So anything that it can't penetrate through, such as a solid piece of mass, you're not going to be able to get your surface below if you have a log in the water or vegetation. But underwater vegetation will collect. You're just not going to get the ground underneath it necessarily. Then how did the sun angle affect your data quality? Was it due to the reflectance off the water?
Yes.
Yeah.
That's one of those ones that was a hard one to swallow. We came back like, oh my gosh, it's going to be such a beautiful data set. We went back out and got it, and it was still beautiful. But the first time you experience getting that reflectivity and kind of false returns, they're like, this doesn't make sense. Everything outside of the shadows or inside the shadows is perfect, but then as soon as you get into the light, it disappears. So yeah, it was. Our team had a lot of fun with that one.
There's more science into that than we could go into, but we won't right now. We won't put you to sleep this morning. What HSI system are you currently flying?
Sorry, what was the question?
Dave asked, what HSI system are you currently flying?
HSI, I'm not familiar with the term.
Hyperspectral instrument, I believe.
Oh, we're utilizing the Specim AFX10.
Then how many returns does the scanner get? The scanner does get, I believe, up to up to 15, I believe, or
I think we've seen 14 on it.
Yeah, up to 15. Ian, I'll actually send you I'll send you some data on it actually, and send you a data sheet and talk. I know it is not DJI M300 supported, unfortunately, but yeah, I think that answers most questions. Yeah, anything that wasn't answered, we'll make sure to email you and answer any questions you have from there. But yeah, thanks everybody for joining on. Thanks, Evan. Thank you, Paul, for going through your full process and how you're able to utilize this instrument.
Yeah, thanks so much for hosting, and thanks for everyone for attending and listening to us ramble on for a bit. It's a fun system, fun to be out there working with it.
Perfect. Hey, thank you guys. Have a good night, everybody.
All right, thank you all.
Take care, guys.